Right, we're looking at this metal acid topic paper. So what we do is, first of all, we look at ores, bores, corks, and mash. I learned this from a student, really useful. This is alkali, this is acid. So alkali plus acid gives water and salt. Then you've got base and acid gives water and salt. Come back down here. If the base is soluble, if you can dissolve in water, soluble in water, it is called an alkali. It's good to know this. Right. What's next? You've got carbonate, whether it's sodium carbonate, whatever carbonate, plus acid gives water, carbon dioxide, and salt. And then finally you have who's that? Metal plus acid gives salt plus hydrogen. Now watch this. Pay attention to this. You've got carbon dioxide, you've got hydrogen, and the question they normally ask is, what would you observe? Right. The thing is, right, you would have bubbles. You would see bubbles, or a better word would be effervescence, but it's spelled effervescent, effervescence. That's a C. Right. 2. The solid that you put in there disappears or gets smaller. And right, I don't agree with this one because it's a bit flaky. Right, in the mark scheme it says flask gets warm. So I don't know about that, but that is one. If you're touching it, yes, but these are the two safest ones, I think. Well, cut across all mark schemes. I don't know whether I've seen this in the third one in all mark schemes, but right. I know it's a bit long, but it's important, right? There's your solid. There's your acid. This piece of equipment is a tap funnel. Right, so remember we're producing what? So it's a metal and acid. So we're expecting salt and hydrogen. So this is hydrogen coming out. And then when you burn it, when you combust it, you get CO2 plus H2O. As the H2O evaporates and hits a cold surface, it condenses and it falls down onto right now. So there's a lot going on here, so just bear with me. Anhydrous, no water, copper 2 sulfate. So this here, anhydrous copper 2 sulfate, is white in color. When you put water on it, it turns blue. So blue is hydrated, hydrous, if I can spell it, hydrous, yeah. Copper 2 sulfate. So remember, just bear this in mind, it's gone from anhydrous white to blue hydrous copper 2 sulfate. So now hopefully you'll understand what's going on here. Okay, let's go. Right, one observation, we've said any one of these. I prefer this one. It seems as effervescence is the best one. Identify the other product formed during this reaction. So you've got magnesium plus hydrochloric acid gives magnesium and hydrogen. Right, you have to remember this. Hydrogen is a diatomic molecule. That means it runs around in pairs. Now I've got to balance this up. Put 2 there. You've got MgCl. Right, I'm going to come here. MgCl. Right, magnesium forms a -1. Chlorine forms a -1 ion. Magnesium forms a +2 ion. Because they're not the same, you cross over. So it becomes Mg1Cl2, but we do not need the 1. So it's going to be MgCl2. So now 1 magnesium, 2 chlorines, 2 chlorines, 2 hydrogens, 2 hydrogens, so it's balanced. So the other product is magnesium chloride. Right, they've not asked for a chemical or a word, so magnesium chloride. Right, hydrogen burns in air to form steam. Write a chemical equation for, right, so it's H2 plus O2 gives H2O. Now we need to balance. The hydrogens are balanced, but the oxygens are not, so I need to put 2 there. So now, watch this, I've got 2 oxygens, 2 oxygens. I've got 2 times 2, which is 4. I've only got 2, so I need to stick a 2 here. So let me get that 2. That's balanced up. What name is used for the process when steam changes into water? Okay. It goes from gas to liquid, so it is condensation. There you go. Right, water drips onto anhydrous copper 2 sulfate and causes a reaction. The product of this reaction has the formula. Right, look at this. Copper sulfate dot 5H2O. This bit is called water hydration. Hydration. There you go, water hydration. Right, state the final color. Copper to sulfate. Remember, it goes from white to blue. Okay, so we don't want to put that into cause confusion. It says state the final color. The color change of anhydrous copper 2 sulfate shows that the liquid contains water. Describe a test to show pure water. So look here. Right. To show water is present, to show water is present, what shall I do? You add the liquid you're testing to white anhydrous copper to sulfate, and it ends up blue. Hydrous or hydrated hydrous copper to sulfate. There you go. That's the test. So you boil the liquid and it will boil at 100 degrees Celsius. You can freeze it as well. Right, let's have a look. Cold water, dilute hydrochloric acid, calcium, copper, iron, magnesium, zinc. I can see straight away that this is the most reactive. This is the next most reactive, and we don't know about these three. When they go to acid, I'm expecting this to be the most reactive. This is the next most reactive. This is the next most reactive, and this is the next most reactive. Just judging by the number of bubbles. So this is unreactive. So just based on that, right, we can say, what can we say? Two metals that react with cold water, calcium and magnesium. Yep. One metal that reacts with dilute but not cold water is iron. Now the reactivity, so it's calcium, magnesium, zinc, iron, and copper. Why I did that, I don't know. Just put the names down. I'm just flexing my chemistry knowledge of the periodic table. Don't worry about it. Too much TikTok. Right, okay, let's keep going. The magnesium powder is added. Colorless solution forms and the gas is given off. When more magnesium acid continues for out, then stops. Some magnesium powder is left in there. So do you know what? Yeah. When a flame is placed at the mouth of the test tube, the gas burns with a squeaky pop. Right, flame, you see, yeah, I like this. You put a flame at the mouth of a test tube and you hear a squeaky pop. That'll be hydrogen. Right, so just why the reaction stops, because all the sulfuric H2SO4, stop it, you're being silly now. All the sulfuric acid has reacted completely. Right, okay. State the name of the colorless solution. It will be magnesium sulfate. How would you separate the magnesium powder? You would filter it using, it's only one marker, yeah. Filter funnel and filter paper. In some fireworks, right, let's have a look. In some fireworks, what happens? What happens in some fireworks? The magnesium powder reacts quickly with oxygen air. You got a lot of heat. When heat energy is produced, you end up with an exo Thermic reaction. Name the compound form when magnesium reacts with the magnesium oxide one. Magnesium 2 plus oxygen 2 minus, they cancel out. Magnesium oxide. Okay, good. Oh, Mr. Boyle. Who's Mr. Boyle? Okay, something happened then, and then. The student repeated Bohr's experiment using iron and dilute sulfuric acid. Right, remember the two observations. Let's look up here. You know, we need to copy this. There you go. Can you see this bit here? Comes up a lot. Okay. That would have been a good one to just copy here. Right, you get effervescence. Effervescence. And the solid would disappear or get smaller. Disappear. They're also saying they will allow a green, really? Green solution forms or colorless solution forms? Green color solution forms. Right, complete the word equation for this reaction. Iron gives hydrogen gas and iron sulfate or iron. Okay. Right, balance equation, complete combustion of hydrogen, right? So you've got, right, let me get this right here, 2H2O, O2, and then 2 there. I think we did that earlier. To show the liquid produced by hydrogen was pure water. Yep, okay, remember, to test for water, we said you use anhydrous, which is white. And when you've added that and there's water in there, it becomes blue. Right, it's good to know that anyway. Put across to show the formula of the compound formed in this chemical test. Copper hydroxide. Okay, to show the formulas of compound formed in this chemical. Oh, right, okay. It's copper sulfate but hydrated. Copper sulfate hydrated. Right, you've just got to know that. And I know it's more than one. So it's not that one. Definitely not that one, definitely not that one. Right, how do you test the physical properties for pure water? We've just done it. You can either boil it and you get 100 degrees C, or you freeze it and it's 0 degrees Celsius, yeah? What property makes it suitable for filling hydrogen balloons? So you want those balloons that you get at parties that are floating up in the air. So it's less dense than air, so it can float. Helium is now used instead of hydrogen because it is, remember, it's a noble gas, so it's inert. It's let's use the word non-flammable. That seems the one that they're using in the mark scheme. Or does not explode. Write an equation. Hydrogen is liquefied. Liquefied. See, this is interesting. You've got hydrogen gas, including state symbols, gives hydrogen liquid. That's it. That's all it was. Right. Right. We'll call it quits at this. So on the other video, we can start that process again, part of the revision. Right. Okay.